In Module 8.1, we're returning to limit problems as a stepping stone to some larger, more important applications that we're going to encounter in Module 9. But for right now, we're returning to limit problems. And now that we've covered derivatives, we can apply derivatives to help us more quickly, more easily evaluate certain types of limit problems. And I want to emphasize that idea of certain types of problems. So this theorem that we're about to introduce has some conditions that has to be met in order to apply that theorem. So in order to use the techniques we're introducing in this section, we have to make sure that one of these following statements is true. So either the limit of some function f as x approaches c has to be equal to 0, and the limit as x approaches c of a second function g has to be equal to 0. So either the limit of both of those functions has to be approaching 0, or has to be approaching positive or negative infinity. And this third option that I actually have in the middle here, if so A and C were about x approaching some real value c. B here is x approaching positive or negative infinity. So in this case, we need f of x to be approaching either 0 or positive or negative infinity, and g of x to be approaching either 0 or positive or negative infinity. So we need to look at those cases and make sure one of those are met. If that's the case, then we can evaluate the limit as x approaches either c or positive or negative infinity. So we might have either of those two expressions. So the limit as x approaches one or the other of those values of f of x over g of x is going to be equal to the limit as x approaches, again, whether it's approaching c or positive or negative infinity, of the derivative of f divided by the derivative of g. And that's going to be true provided that that second limit exists or is equal to positive or negative infinity. So what's important to note here about this rule, L'Hopital's rule, is again one that we have to verify these conditions in order to apply this rule, and that when we're looking at the derivative of f divided by the derivative of g, this is not the quotient rule. So what we're actually just doing is taking the derivative of the function that was in the numerator and just copying that over, the derivative of the function that was in the denominator and carrying that over. So as long as these conditions are met, we can make use of L'Hopital's rule to hopefully more quickly find the limit of this function. So again, to apply this theorem, it's going to be critical that we verify the assumptions. So in order to verify those assumptions, what we want to do is first start off by trying direct substitution. To see if we can get the limit as x approaches c, or again, actually we've got those two different options, the limit as x approaches either c, or x could be headed to either positive or negative infinity, so we have a couple of different types of problems there. If we can get the limit of f of x over g of x to be equal to 0 over 0, or infinity over infinity, whether those are positive, negative infinities, doesn't matter. So the first thing to do is just try direct substitution. If you don't get either of those results, so if you don't get 0 over 0 or some version of infinity over infinity, then we cannot use the theorem and the techniques that we're introducing in this section.